Taking a look at one of the questions from section 3.11's homework, it is talking about a circle that has an area increasing at a rate of 2 centimeters per second squared, and we want to know how fast the radius is changing 3 centimeters. So how fast the radius is changing when the radius is 3 centimeters. Alright, so alright, so the first thing I want to do is write down the formula for area. So area is pi r squared, and then if we introduce the differential dt, we can relate the rates here. So take the derivative with respect to t on both sides. So that gives us dA dt equals pi times 2r dr dt, and then I can rewrite that just to simplify. So dA dt is equal to 2 pi r. Just put the 2 first. Could have done that from the beginning, but it's okay. dr dt. Okay, so I've got my original equation and I've got my related rates equation. Now I also have some information that I know. The area of the circle is increasing at a rate of 2 centimeters per second squared, so that's actually dA dt. So I'm going to plug in 2 for dA dt, and for part A, we're looking where r is 3. So I have a value to plug in for dA dt, I have a value to plug in for r, and it's going to allow me to solve for dr dt. So these are conditions I can use in part A. Alright, so for part A specifically, we have 2 equals 2 times pi times 6 dr dt, and I can divide the 2's off, divide off the pi and the 6. That'll give me 1 over 6 pi equals dr dt. Sorry, whoops, I accidentally already multiplied 2 times 3 and I plugged that in. That's really a 3. My bad. Again, r is 3. In my head, I saw my 2 and my 3 and I made a 6, even though I had written down 2 times 3. So 2 times 3, the 2's divide off, gives me 1 over 3 pi. So 1 over 3 pi should be dr dt. dr dt is 1 over 3 pi, and the units on that are going to be centimeters per second. Okay, so that should be the first part, and we can check that. I think this one was already answered, so if we go back over and check, yep, 1 over 3 pi is the correct answer, units centimeters per second. Now part B, I'm not going to go ahead and finish part B, but because they did not give me the radius, they gave me the circumference, all I need to do is take the formula for circumference, which is 2 pi r, and I need to plug in 4 because they told me that the circumference was going to be 4. Plug in 4 for the circumference and solve for r. And then once I have r, again, I just plug those things back in. Continue to plug in 2 for dA dt, plug in the new value that I get here for r. Alright, so I guess it won't hurt to finish it. That's 2 divided by pi for our r value, and then that would give us 2 equals 2 pi times 2 divided by pi dr dt, and so the pi's cancel, the 2's cancel, that gives me 1/2 equals dr dt. So in part B, dr dt would be 1/2 centimeter per second.